Hey everyone, and welcome. You know that feeling, right? You write this piece of code, you're super proud of it, and then, out of nowhere, it crashes. We've all been there. Today we're going to tackle one of the most critical skills for any Python programmer, error handling. This is seriously what separates a fragile script from a really robust professional application. So let's dive in and learn how to build code that doesn't just work, but actually lasts. I love this quote from a Free Code Camp article because it perfectly captures that universal developer moment. You build something, it works like a charm, you ship it, and then 2 weeks later, you get that dreaded message. It's broken. It's that embarrassing, fall flat on your face moment that, honestly, could have been prevented. We've all felt that. So that's the big question, isn't it? When your code runs into bad data, or it can't find a file, or maybe a user does something you just never saw coming, how do you stop it from just giving up? How do you build code that can take a punch and keep on ticking? Well, the good news is Python has a built-in safety net. It's this really powerful way of managing those runtime errors. You can think of it like a lifeguard, constantly watching your code, ready to jump in and save it from drowning the second it gets into trouble. And this is all about something called exceptions and the try-except block. So what even is an exception? Well, in the simplest terms, it's a signal. When your code hits a problem it can't solve on its own, like, say, dividing by 0 or trying to open a file that doesn't exist, it raises an exception. It's basically Python's way of throwing its hands up and yelling, "Whoa, something weird just happened here, and I have no idea what to do next." And this right here makes the difference crystal clear. Without error handling, that exception signal we just talked about is a total train wreck. It brings your entire program to a screeching halt. But with a try-except block, you're essentially building a detour around the crash site. You catch the signal, you deal with the problem gracefully, and then you let your program continue on its way. It's the difference between total failure and a minor hiccup. All right, let's get into the mechanics of this thing. The try-except block is your main tool, and really understanding how your code flows through it is key. When you wrap a piece of risky code inside a try block, there are really only 3 ways it can go. So, path number 1. Everything goes perfectly. Success. Path 2. An error happens, but you are ready for it, and you catch it. And path 3. An error happens that you totally did not plan for. Let's start with the best-case scenario, the happy path. So this is the happy path. Let's say you've got a line of code, something simple like results equals 10 divided by 2. You put that inside a try block. It runs, no problem. Python sees everything went smoothly, and so it completely ignores the except block. It just skips right over it. Your program just keeps on trucking. Clean and simple. Okay, but now what if the code was result equals 10 divided by 0? The second Python hits that impossible division, it stops dead in its tracks. It doesn't even bother looking at any other lines inside that try block. Instead, it jumps straight down to your except block, runs whatever recovery code you put in there, maybe it just prints a helpful message, and then it carries on. Disaster averted. But here's the tricky one. What if your code was, say, result equals 10 divided by x, and you forgot to define what x was? You might have planned for a 0 division error, but what you actually got was a name error. In this case, your try-except block doesn't know what to do. The exception is unhandled, and the whole program comes crashing down. This is super important because it shows us we need even more precise tools to manage our code's flow. And to get that fine-tuned control, Python gives us 2 more awesome optional clauses, else and finally. These things let you choreograph exactly what happens and when, giving you total command over how your program behaves when things go right or wrong. Let's check them out. The else block is pretty easy to wrap your head around. Just think of it as your success clause. Any code you put inside the else block will only run if the try block finishes completely without a single error. It's the perfect spot for code that you want to run only after the risky part succeeds. Now finally, this one is your always-on cleanup crew. It runs no matter what. I mean it. Whether the try block worked, an error was caught, or even if an unhandled error is about to crash the entire program, the code in finally will execute first. This makes it absolutely essential for stuff like closing a file or a database connection. You always clean up your mess. So, now you know the tools, but how do you use them like a pro? Well, the single most important rule in good error handling is specificity. It's all about catching the right errors, not just any old error. This quote from a user on Reddit just nails it. If you can't actually do something useful to fix a problem, you probably shouldn't be catching that exception. You should let it bubble up, which just means if your function can't handle it, maybe the function that called it can. And if nothing can handle it, the program crashes. And you know what? A crash can actually be a good thing. It shines a big, bright light on a bug you didn't know you had and forces you to fix it. And this table here breaks down that risk perfectly. Look, writing except exception is so tempting, right? It feels safe, it catches everything, but it's actually really dangerous. It can swallow up bugs you never saw coming, making your code fail silently. And let me tell you, that makes debugging an absolute nightmare. But catching a specific error, like value error, means you're only dealing with a problem you know how to solve. If some other weird error pops up, the program still crashes, and that's good. It tells you exactly where the real problem is. So what kind of things should you be looking for? Well, here are the usual suspects. You'll get a value error if you try to turn the word hello into a number, a type error if you try to add a number and a string together. Key error and index error happen when you look for something in a dictionary or a list that just isn't there, and file not found error. Well, that one's pretty self-explanatory. Getting to know these is your first step to writing really effective, targeted error handling. Okay, let's pull all this together into a simple game plan. First, you wrap your risky code in a try-except block. Second, you use else for any code that should only run on success. And you use finally for all your essential cleanup. And most importantly, be specific. Only catch the errors that you actually know how to handle. That's the whole toolkit for building code that anticipates problems and deals with them with grace. At the end of the day, doing error handling right doesn't just stop your programs from crashing. It makes your applications more resilient, more reliable. It's the mark of a developer who's really thought through all the edge cases. And honestly, that just makes you a much more effective and professional coder. So I'll leave you with a question to chew on. Go look at a piece of code you're working on right now. Where is it most likely to break? What's the first specific error you're going to go out and catch?